Morning, students. Morning. My name is Mr. Black, and today we will be learning about the basics of the periodic table. So as you can see, there's a periodic table behind me, and it is made up of rows and columns. The rows are called periods, and they indicate the energy levels occupied by the electrons around the nucleus of each element, and these are all elements, every one of them. And there's 7 rows. Also, there is columns called groups, and they go from 1 to 18. So this is not an accurate periodic table, but you do have an accurate one in your notebooks, textbooks on page 64, so you can look it up while you're studying for the test that we have tomorrow. And this is the modern one, which is created by Russian chemist Dmitry Mendeleev, and that's basically all you need to know for tomorrow. But I would suggest going through your textbook and researching what alkaline, actinides, non-metals, metals, and noble gases are, just so you guys can go into depth on more of the test, because class is almost over. So have fun on your test tomorrow, kids.
And this is so hard. It's our first class. And have you studied?
No. This is so retarded, and the teacher's just like sucks, and I don't like this.
Okay, so how are non-metals and metals grouped? How does that work?
Well, I just know that metals are harder and denser than those in groups 1 and 2, but tougher and less dense than the transition metals. Most of them are found on compounds in nature.
Non-metals are under group 17 and are highly reactive and are called halogens.
Wow. And what about alkaline earth metals? How does that work?
Well, the alkaline earth metals are less reactive than the alkaline metals.
And the alkaline metals are highly reactive, and the name comes from chemical reactions with water in which they produce highly alkaline substances. Yeah.
This is really weird, and we have to understand all this for the exam. It just seems like so much. And then transition metals, groups 4 and 12, all shiny metals found naturally, less reactive than groups 1 and 2, elements we usually think of as metals. Alright. And the lanthanoids and actinoids are like separated, right? They're separated from the periodic table. Yeah? Yeah, okay. Groups 3. So they include shiny metals and reactive elements. Lanthanoids are abundant in the Earth's crust, but difficult to separate from their compound. And all actinoids are radioactive. Whoa, so much information.
So guys, what are noble gases?
Well, all I know about noble gases is that they are located in group 18 and that they are called also inert gases because they don't react chemically with other elements.
I think the only reason the periodic table is set up the way it is because there's obviously like similarities, physical and chemical properties or characteristics of elements that are put in the same place. Like the atomic number, it increases, and as the atomic number increases, the table keeps on going. We also have the atomic mass to take into account, and this law that Henry Moseley, an English chemist, said was that when elements are arranged in order of increasing the atomic number, there's a periodic pattern in their chemical and physical properties. So that's why they're just grouped the way they are with all these names, the alkali, the alkaline. So I think we should just take this test. I think I'm ready.
Yeah.
Okay, yeah, me too.
Basic recap of what the test is going to be about. What patterns can we see? What is a period? What is a group? How are metals and non-metals grouped? In what ways are elements near each other similar? Are there patterns of reactivity, boiling points? Which types of elements will react with which and how? So, good luck!
The patterns we can see in the periodic table are columns that are called groups, which have similar chemical and physical properties, and rows called periods, which indicates the energy levels occupied by the electrons around the nucleus of that element.
The ways elements near each other are similar is that they are arranged in order of increasing atomic numbers and mass.